Hey everybody, I hope you've had some time to rest and relax. Let's get back at it. It's time for math with Mr. Troy. Alright, so we are starting our next unit, which is on quadratic equations. But we are going to start with just a definition of complex numbers. So all numbers that you have dealt with thus far have been complex numbers. They have just been real examples of complex numbers. So complex numbers are numbers that are built of a real part and an imaginary part. So something like 6 minus 5i would have a real part of 6 and an imaginary part of negative 5. Real numbers have no imaginary part, and imaginary numbers are any number that have an imaginary part. If we have something like 3i, that is a pure imaginary number, while 6 minus 5i is an imaginary number, and it's a complex imaginary number, a complex number, but it is not a pure imaginary number because it has a real part as well. The additive inverse of a complex number is what you would add to it to make 0. So for example, the additive inverse of this complex number is negative 6 plus 5i. So we're going to start this video with some rules on square roots. First, square roots of perfect squares can be simplified in a single step, so you should know all of your perfect squares from 1 to 20. Square roots of primes can't be simplified at all, so if you're taking the square root of a prime number, you know it can't be simplified. Square roots of other composite numbers, so things that maybe aren't a perfect square, can be simplified if one of the factors is squared. So for example, when you look at the square root of 108 is 3 times 36. 36 is a square factor. The square root of a fraction is equivalent to the fraction of the square root. So if I have a square root of 7/9, that can have a denominator of 3. And if there's a rule you don't know, square roots are exponents. So you probably learned this sometime in Algebra 1, and hopefully you stored it in the back of your brain, but who knows? X to the 1/2 and the square root of x are the same thing. So if you don't know if or why any of these rules are true, the way you tell is by thinking about exponent properties, because you do know those. So if you want to simplify square roots, only like roots can be combined. If I want to add the square root of 3 plus the square root of 5, there's nothing better that I can say than just, well, that's the square root of 3 plus the square root of 5. Nowadays, you can plug that into a calculator and get a decimal, but back in the old days, you would have just had to memorize these and then, apply it in whatever way you needed to. Combining like roots is exactly the same thing as combining like terms. So if I say 5 root 7 minus 3 root 7, I approach that in exactly the same way as I do 5x minus 3x. 5 of something minus 3 of something equals 2 of that thing. Doesn't matter if I'm talking about x's or if I'm talking about square roots. Now, finally, you may need to simplify to realize that some roots are like roots. So, you may not realize that root 27 and root 48 have something in common. You might have to simplify before you can add those together. Okay, so quick reminder on how you simplify square roots in general. And there are lots and lots of different ways to do this. The most common way to do this is to think of something that divides into the number that is a perfect square. So in this case, I look at 208 and I say, well, that looks like it's divisible by 4. So that's really 2 root 52. And we can either put the multiplication symbol there or not. It's more customary not to. Well, then you would look at your remaining number and say, well, does that simplify at all? In this case, 52 is 4 times 13. Well, in all cases, but in this case, that's what we're looking at. So this is really 2 times the square root of 13, or 4 root 13. Now, a faster way to go about this is if you happen to know that this number, the radicand, is divisible by 16. So if you happen to know that 208 is 16 times 13, then you can get to the correct answer in many fewer steps with fewer chances for error. Okay, so that brings us to imaginary numbers. I is the imaginary unit. Way back when, hundreds of years ago, people were looking at this equation, x squared plus 1 equals 0, and saying, why doesn't that have a solution? So we said, well, what if you said x squared equals negative 1? Well, we need a term for that because, there's no square root of negative 1, so what do we do about that? So there's no real number that makes this equation true, but what we do when that situation arises is we say, can we make something up? And then, does everything that follows follow in a logically equivalent way? Or did we just make something up that was contradictory and didn't make any sense whatsoever? So we can use this new definition to simplify a bunch of square roots of negative numbers. So by those same rules as before, we can split negative 4 into negative 1 and 4. The square root of negative 1, as previously discussed, is I, and the square root of 4 is 2. So this is the same thing as I times 2. Now it's a little weird to refer to it that way, so we're going to actually refer to that as 2I. By the same token, we could say, well, this seems to be 25 times 3 times negative 1, or 5 root 3I. Now, people write this in two different ways. Some people will write 5 root 3I. Some people will write 5I root 3. Either one of these is acceptable. If you're writing in standard form, which is that a plus bi, you want to use this way. Okay, so what if you have something more complicated, like the square root of negative 3,888? Since this is negative, I know my final answer is going to have an I in it. So maybe I want to start by saying that this is the square root of 3,888 times the square root of negative 1. Now, I'm relatively sure that this is divisible by 4, because it ends in an 8, or it ends in an 88, rather. But I want to keep going. So I want to think about how I could break that up. So an alternate approach to take, other than the kind of pick a square and factor it out method, is to use a factor tree. You might remember these from elementary school or middle school. Here's how that would be useful to us. By using a factor tree, we can see that 3,888 is 16 times 81 times 3, which means its square root is 4 times 9 times root 3. So all told, this simplifies down to 36 root 3 I. All right, everybody, that's as good a place as any to stop. Let me give you a quick hint at where we're going. Oh my goodness, I've disappeared. So we are going to try and figure out what happens when you square I, cube I, or raise I to the 4th power, so on and so forth. So this is something to ponder as you wait for class to begin. Thanks for watching. Hope you had a good one. See you in a bit.